welcome back to Decaf Math. I hope that you are doing very well. So today I wanted to go over integration by parts. Okay? And this is a method that you can use to help you evaluate integration by parts. So, when you have an integral, you can try to use the basic integrals that we know. You can refer to my colorful integral video if you want to review some of our basic integrals. And then you can try substitution, and I haven't made a video about that, but if you want to hear it, I probably will. And then you can try integration by parts. So typically you will learn about integration in calculus, whether you're taking AP calculus in high school or calculus in college, but that's usually the first time that you hear about integrals. So integration by parts, there is a main formula to know. Take your time memorizing it, but we will kind of go into it a little bit today and maybe build some intuition. And if you want to work through specific problems, I'd be happy to do that in the future. So the general equation is u dv equals uv minus the integral of v du. Okay, uv's all over the place. But let's see, this is the main formula. To know. Integral of u dv equals uv minus the integral of v du. What does this all even mean? Okay, so the idea is that if we have a problem, integral that we're trying to solve, the main parts here, notice, are it's integration by parts. Of course, so we're going to have parts. And the main parts are u du here, which is the derivative of u. I have dv and v, right? And v, of course, and then there's u, but v, right? So v and dv is the derivative of v, or you can think of v as the integral of dv, because we're talking about derivatives, right? So to go from u to du, I take the derivative. From dv to v, I take the integral. Okay, so the four unique parts, of course I'm using u and v and du, but the four things that we know, the pieces, are u, du, dv, and v. And I'm writing them in this bizarre order for a reason, and I'll show you in just a second. Okay, so the general idea is we're going to start with this side, when we work with our integral. And we want to split the integral that we're finding into these parts. And then we can choose u and dv so that our integral looks like this form, u times dv, or u dv. Then I plug into this equation, and hopefully, just following each of these parts, hopefully this thing becomes easier. So the whole goal is to simplify our integral, okay? So if we couldn't solve this any other way, we choose parts, and then we plug into this equation, and hopefully this integral of v du part is easier and we can actually calculate it, okay? So let's work through an example. Let's say we have the integral of x e to the 3x, okay, dx, so with respect to x. So here's the thing. We can try to do our regular integrals, our basic integrals, but you'll notice that we can't really do it here. We know the integral of x, and we know the integral of e to the x, or e to the 3x with substitution, but when these two are multiplied together, we can't use our basic integrals. So point one that I'm going to make is that this is not equal to the integral of x dx times the integral of e to the 3x dx. Okay. Sad face. Not. Okay, so we can't distribute this integral. Okay? Okay, so that's first thing. Next thing is if we tried substitution. So if we tried 3x, like u equals 3x or something like that, du would be 3 dx. There would not be an x factor here, okay? So we would not be able to do substitution here because we still have this issue with this x. So that's what's causing us problems. So that would kind of make me think, hey, I'm going to try integration by parts. So what we're going to do is try to break this up in such a way that it looks like u dv. So right now I just have x, some kind of function thing with dx. So I'm going to break this up into parts, okay? So what parts I can choose? I can choose whether this is u or this is u, but I just need u dv, okay? So I could, for example, say x is u and e to the 3x dx is dv. Okay, I can choose to make this whole thing to look like u dv, but I can also choose, for example, I could also choose u is e to the 3x, and then x dx could be dv. So there is a little bit of creativity involved here, okay? So just remembering what our goal is, which is to pick the parts so that we can actually make our lives easier, because potentially if we pick the wrong parts, it's not going to be wrong if you plug into this, but this might not make your life easier. You might just get another complicated integral, and that doesn't help. Now, there are more complicated integration by parts where you have to do it twice or multiple times to get an answer. Like you do it by parts and then you have to do this part by parts again. But in general, when you're trying to find this, your overall goal is to make things easier on yourself. Okay, so life is complicated enough as it is, so we like things simple around here. So if we look at the pattern though, we are picking u and dv, okay, from this side and on this side. So that's why I wrote it like this, because I'm actually picking u and dv, and then from those I get my du by taking the derivative and v by taking the integral, okay? So if I think about it here, my u, I'm going to be getting a du, the derivative, in this integral part. So my goal will be to find a u that makes things easier once I take the derivative. So in my mind, I'm thinking, okay, u being x is nice because the derivative of x is 1. So I like that. I like e. So I'm gonna say let u equal x. And I do this like on the side, okay? Then my dv is going to be this stuff, dv. Okay? And so I'm gonna write let u equal x and dv equal e to the 3x dx. Okay? Let me move over. Okay, so from here, because I chose this, so this part gets confusing because what am I choosing and what am I calculating? So I am always choosing my u and my dv. Okay, so now I have u dv, but I need to plug it into this equation. So I also need to know the values of v and du. I'm gonna need to calculate those, but that's not so bad. If u equals x, then du equals the derivative of x is 1 dx, which I'll just write as dx. Now remember, if I'm taking the derivative on both sides, I have to have dx. Du equals dx. Okay? From here, I have to get v. So remember, the integral of dv is going to be v, integral my derivative. And if you're concerned about the plus c's and stuff, because we're doing indefinite integrals here, we can do it at the very end when we are actually calculating the integrals. They end up kind of canceling each other out, so we'll add the plus c for indefinite integrals after all of this. So I'm not going to do it here like v plus c. We don't need to worry about all that. It works itself out. So to go from dv equals e to the 3x dx, I take the integral of this, the integral of e to the 3x dx. Okay, so this thing is one that we know. If you want, you can do this by substitution if you can't look at it and know. Just be careful if you do u substitution that u is not this u, right? So you kind of do a little side note here. If I want to, I can just like let t equal 3x, dt equal 3 dx, and then whatever helps you. If you want to do integral of e to the t, right? T over 3, if it helps you to see that. But if you're already familiar with it, you'll get e to the 3x over 3, right? Okay, I'll do another video on u substitution another time, but the point is that the integral of dv is actually, it's doable, right? We can find what that integral is. So we have dv, we have v, we have u, and we have du. Let me highlight those parts because that's what we need. So u, dv, du, and v. So we have our 4 pieces here. Okay, so now we just need to plug into this. Plug and chug. Okay, so when I put this in, I get uv. So u is x, v is this stuff, e to the 3x over 3. So I get x e to the 3x over 3, that's my uv, minus the integral of v, which we already had, e to the 3x over 3, du. Du is dx because we chose u, which is x, which is so nice because now du is just dx, which is so nice because it's just one dx or just dx. So, did we do a good job picking our u and v? Well, now what do we do? So this is our integral, but this is nice. So we got our problem, which we couldn't solve, u dv, but now after we plug this in into this we actually can calculate. Again, we're basically taking the integral of e to the 3x another time, which we already just did, with the third, which we can pull out, right? So our answer would then be x e to the 3x over 3 minus 1/3 times e to the 3x over 3. One more time, right? The integral of e to the 3x is e to the 3x over 3. So I pull the 1/3 out and I do it one more time. And then plus c. That's where we can add the c at the very end. So this is actually really nice because we got rid of our x factor in front basically by doing our parts. So now from here you can simplify that if you want. So we can do, you can put this all on one layer if you like. You can rearrange how you like. So either you put it all by layer, I mean like a common denominator. So you could do 3x e to the 3x minus e to the 3x over 9, if that floats your boat. Whatever you want. You can factor out the e to the 3x and just have 3x minus 1, as long as you don't break the math, and hopefully I didn't just break the math, but you get the idea. You get the answer, and you put the plus c at the end if it's an indefinite integral there, okay? So, and then you just put the plus c at the end if you don't have your bounds, okay? So, in general, the key idea is finding your u and your dv. Now, don't get too stuck in like specific patterns. You don't always set x to equal u. You don't always set the thing in the front to be u and then the second one dv. Really, in your mind, you want to pick things that make your life easier. So knowing that you're going to eventually be doing the integral of v du, make sure you're picking a u that you know the derivative of, and make sure that you're picking a dv that you can easily calculate the integral of to get your actual v, right? So as long as you keep those in mind and you actually get to a step, so this thing that we couldn't calculate now becomes an integral that we can calculate, either just by knowing it or by doing u substitution, but either way it's a method that we know, then we can simplify that. So now that we can calculate it, we have our actual answer. And of course, if you want to check, because it's nice, especially if this is like on a test, you can just take the derivative of this to see if you get your original problem. And if you do take the derivative of this, remember we have a little bit of a product rule here going on, we have a little bit of chain rule going on, but hopefully we get that. Okay, so I hope that kind of clarifies things a little bit, especially if this is the first time or you recently heard about integration by parts and you're just like, uv, dv, what is going on? I know it takes a little bit of time to wrap your mind around, but I hope that this helps, and don't hesitate to reach out if you want more support or help. And if you are not taking calculus and this is just all like gibberish to you, I hope that this was relaxing nevertheless. So I will see you soon, and do introduce yourself if you are new here. Thank you